Hi everybody, in this video we're going to talk about different types of operations that show up in math, and also we're going to talk about the relationship between these operations. So the operations of addition and subtraction and multiplication and division are called binary operations because you take two inputs and you do something with those inputs to give you a single output. So with addition, if you have two things plus three things, the operation of addition takes those two and three things and combines them together, which gives you an output of the number 5. In subtraction, you have your first input, and the second input tells you how much you're going to take away from the first input to get your output, which is the number 2. And these two operations are called inverse operations of each other because they undo each other. Like, for example, if I did 2 plus 3 and I got the output 5, well, I could get back to where I started, or I could undo the operation of addition by doing 5 minus 3, which gives me the number 2. So those two operations are called inverse operations of each other. And then the next operation is multiplication. So in multiplication, the first number tells you how many items you have in a group. And then the second number tells you how many copies of those items or how many groups of 4 you have. So if you have 7 groups of 4, if you count up all of them all together, that gives you the output, which is 28. And just like addition had an inverse operation, multiplication also has the inverse operation of division, because you can use division to undo multiplication. Like if I had 28 things and I divided them up into 7 groups, that would give me 4 things in each group. And so multiplication and division are inverse operations of each other. Another operation that we have that's also a binary operation is the idea of exponents. Because the idea of exponents is that you have your two inputs, and the base of the exponent is the number that you'll repeatedly multiply, however many times the exponent tells you to multiply. So in this case, we have a base of 2 and an exponent of 5, which means that you multiply 2 by itself 5 times, which gives you the output of 64. So this is a binary operation because you have two inputs that gives you a single output. And the inverse of exponents is the idea of roots. So a root is also a binary operation because you input the argument of the root, then you also input the type of root it is. So the most common one we work with is a square root, but there's also things like fifth roots or cube roots or fourth roots. And basically what a root does is it undoes an exponent. So since 2 times itself 5 times equals 64, the fifth root of 64 equals 2. So exponents and roots are inverses of each other, similar to how addition and subtraction are inverses and multiplication and division are inverses. And all 6 of these operations are related to each other in a way that creates the structure of how math sentences are written. So the way that I like to kind of think about it is that it's like a pyramid that builds on itself. So when you first introduce the idea of addition, you introduce that basic operation, and then you introduce its inverse, which is subtraction. And the way that I like to think about it is that addition and subtraction are on the same level of the pyramid because they're inverses of each other and they undo each other. Then the next layer of the pyramid is created when you have repeated addition, which is the same thing as multiplication. Because if I do 3 plus 3 plus 3 plus 3 4 times, that's the same thing as 3 times 4. So the next layer of the pyramid or the structure of operations is created by doing repeated addition. Repeated addition creates multiplication, and then division is the inverse of multiplication. So again, it's on the same level because those two are inverse operations. And then the next level of the pyramid comes from repeated multiplication because if you multiply a number by itself repeatedly, that creates an exponent. Like if I do 2 times itself 5 times, that's equal to having 2 raised to an exponent of 5. And the roots undo the exponents. And we'll talk more in later videos about why this way of thinking about operations is useful. But the main idea I want to get across in this video is that the 6 operations or the 6 binary operations that we use in math are related to each other in a very logical structure. And in addition to having binary operations, we also have what are called unary operations. So the root word un means one, and a unary operation just takes one input to give you the output. So in absolute value, you take an input of one number, and then you find the distance from zero of that number, and that's what your output is. Another example of a unary operation that isn't really used much in elementary school, but it is used later, is the idea of factorials. So a factorial takes a single number as an input, and the output is that whole number decreased by one until you get down to the number one, and you multiply all those whole numbers together. So this is really useful in combinatorics and probability and things like that. So we won't really be using it a lot, but I just wanted to give it to you guys as another example of a unary operation. So binary operations take 2 inputs and give you an output. Unary operations take 1 input to give you the output. So I hope that's a helpful review of the different types of operations. If you have any questions, let me know.